On today's podcast, we have Dr. Liz Gilligan, the CEO and co-founder of Material Evolution. Liz, thank you so much for joining us here on the Reindustrialized podcast. We're really excited to have an opportunity to talk more about you and your background, as well as the company that you're building.
I'm so excited to be here and talk all things cement.
Well, let's get right into it. What led you to becoming an entrepreneur working on one of the world's biggest challenges, which is cement?
Yeah, I think it's a great question. I don't think I ever wanted to be a founder. I didn't know that was a thing. I was just obsessed with cement. I know who knew that was a thing.
Okay, you got to give me some details here. You were obsessed with cement. Since when? Does it start at like 5 you're obsessed with cement? Does it start at 10, 20?
Yeah, no. So I did my undergrad in architecture. Wanted to be an architect to build the cities that would change the world. Realized I'm not a very good architect. I'm actually quite a bad architect. But obsessed with materials. How do we build things? Why are we building them the way we are? So during my time at Foster & Partners, worked on projects like the Apple campus and Bloomberg, kind of really discovered cement. Fell into a PhD in the subject and was like, oh, it's the second most used material in the world after water. It's a fact that still blows my mind. And then it's 8% of global emissions, all of these things. And during my PhD was like, oh, we could go and write about this for the next 10 years. And that'd be great. And I'd probably be applauded in academic circles. But the planet's on fire. How are we going to do something about this? So the company was started with that. I had never really been in the entrepreneurial world, in the startup space. I didn't know that was a thing. And kind of was like, oh, I guess we're going to go learn how to do this because the planet needs it.
So when you talk about your research and your PhD on cement, were you looking at the scientific properties of it, or were you looking at more the commercial, historical, socioeconomic elements of it?
Yeah, so my PhD was in bioreceptive facades made of industrial waste. I know, a mouthful, right?
And from architecture to bioreceptive facades based on industrial waste. How did that jump happen?
Yeah, so I was really lucky. I got to write my PhD subject. I got to choose the professors that came in on it, and they were architecture, engineering, science. So we built this project together, and it was hands-on in the lab making stuff. We did a project at Google where we trialed these facade panels. So it was very hands-on, make stuff, see if it breaks, kind of very entrepreneurial. But yeah.
Had you ever been in the lab prior to this?
Not since secondary school.
So it was kind of like you got a chance to build a panel essentially of experts for you to explore this topic. That's really, really cool and not very common for PhD programs.
Yeah, no, the PhD program was great. I always thought that everyone in the school was a resource to me. So I was like, how do we network through that? You know how to use that. You've got a really cool machine there that we don't use. Can I come and play with that? And summers at universities are the best time to do anything. Like, every student's gone. It's basically free reign of every equipment they have.
And you are using all of them.
Yeah, and just go and find everyone. Go and chat to them. Like, there's amazing people doing amazing things that I think a lot of people overlook. So go and talk to them. They love being spoken to. I think it's a great way to network through a kind of university. And I guess use that in the entrepreneurship as how do you network through an industry?
And so while you were doing your studies, were you having conversations with the industry experts, or let's not call them experts, let's call them incumbents. I'm not super familiar with the cement industry, but I always think of it as kind of like a mafia. And there's like, mafia. I know there's like, a Russian player, there's like a Turkish player, there's like a Mexican player, a Brazilian player, and there's like one kind of in every country, the major economies, and they don't really play nice together. But they will collude to like do things. So did you, as you were going through this process of doing the research there, were you also learning about sort of the industry challenges there?
Yeah, so really linked to like, how do you scale this? What are they doing now with their research? How are they thinking about this problem? And the stuff we're doing now isn't actually based on my PhD. So during this, a side hustle was the stuff that I had learned from industry, what was actually working, what wouldn't. Kind of shooting holes in my PhD and being like, this doesn't scale. Like, this is great and fun, but this isn't scalable. And then being like, but the real problem is cement. Actually, how do we actually change cement? What do we do there? How does that come together?
And so let's get into the science now. Like, what exactly is Material Evolution doing to change cement?
Yeah, so this actually started in my parents' garage. So it was this quick route to professorship I was offered, or go start a company.
Those are two pretty extreme options.
Yeah, it was. I thought, what will I care about in 20 years' time? What will I regret not doing? And I think starting a company was the thing I'd regret more than going to be an academic. So we had no money.
Which is often the case, starting a company.
Always, right? It was COVID, so we couldn't even rent any lab space. So I made a great PowerPoint to my parents of why they should get everything out of the garage. And we needed some space to build our first kind of prototype. We bought our first machine off of eBay.
What machine did you buy off eBay?
We still have the machine. It's she is a beauty.
Wait, what is it?
So it's so concrete testing is a bit archaic sometimes. So it's you're squashing blocks basically to get their compressive results. And the machine hasn't changed in like 30 years.
So it's just like a big thing.
It's a big industrial press. And we found one on eBay, and
who was selling it?
I don't even know. And we were like, this is so good. How have we found this? You know, like fate. Like you're like, and it's so good. And we still use the machine now.
Wow.
She is an artifact, and she is the trusty faithful.
She'll probably last forever.
I mean, it's basically a big piece of steel that weighs a ton. An actual ton, and just
it's actually a ton.
Actual ton.
Okay.
And it just seems to last forever.
Okay.
Yeah.
So you buy this piece of does she have a name?
No, we haven't named her.
You should name her.
I feel like if it dies, it will be too distressing.
Oh, that's fair.
So it's just the artifact in the company.
Okay. So the artifact, you buy her, and you are in your parents' garage, and are you just breaking up concrete?
No, so we don't believe there's going to be one material to save the world.
Okay.
We think that there's going to have to be a play between hardware and software to get there. So we believe that you have to blend them together. So we're starting to build our own AI ML algorithms in the garage and trying to feed those into industrial wastes whilst proving out our technology of alkali fusion, which is a non-heat process that forces phase changes on particles. Mm-hmm. So makes particles get sticky and turn into cement.
And maybe let's do a primer for us non-technical people about the cement process, because it is really fascinating, and we as human beings have been making cement for a very long time. Like, just walk us through the normal process of how cement is made, like, you know, that we've been doing for the past, 2,000 years since the Romans, I guess.
So normal cement's made using limestone. And we're kind of grinding that with a few other things to make our cement formulation. And then that goes into a big industrial furnace, so a rotary kiln. It's fired at 1,500 to 2,000 degrees to get cement. It gets made into clinker then, so little, like, stones. Then it's ground into the powder that creates the grey cement that we add water to.
So then we add water to it, and then it, like, you talked about a phase change. Go ahead.
Yeah, so in the heat piece, it's where it's getting its phase change. So the Industrial Revolution has always been about phase changes during heat. We're saying actually maybe the phase changes aren't with heat anymore. Maybe they're with microwave, sonic, mechanical. Maybe there's lower carbon options of how we can get particles to change.
And so now to fast forward, that's the old way of, like, creating concrete. What is the material evolution way of thinking about creating concrete? Obviously, there's a technology, the SAS, or not SAS, but the software side of it. But let's talk about the physical elements.
Yeah, so we've developed a reactor that uses our process called alkali fusion. So it's a microwave, sonic, or mechanical activation process that gets these particles to go from being non-active to active. So the thing that heat does in cement, we're doing that in a selection of those three ways.
And so when we talk about the emissions from cement or concrete, sorry, I'm using the words interchangeably, and I know that they're not interchangeable.
So how I think about it is cement's the flour and concrete is the bread.
The bread.
We only make the flour.
So you're only making the flour, which is the cement. When you talk about the emissions in that space, are the emissions related to this firing process that you mentioned of actually getting the materials to change? Is that the only place where the emissions happen, or are there other places along that journey to it becoming concrete that there are a lot of emissions?
Yeah, so for the cement part, the two emissions come from the heating process.
Okay.
So just it's super energy intensive. It's about 1,600 kilowatts per ton. Ours is about 33, just for comparison.
Wait. The normal is 1,600. And yours is 33.
Yeah.
That's incredible in terms of...
So incredible in terms of just its energy usage.
Yeah.
And then the next bit comes just from turning the limestone into cement. So it's emitting all of this carbon during that process. So it's a process you can't get rid of. It's a part of the chemical reaction to get cement.
Okay. And so what you all are doing with material evolution is now, reducing this heat element, but is the turning process still there, or is that something that's always going to exist, or is there a way?
No, so we don't use limestone. We're using industrial waste. So we don't believe that. We think there's lots of great players doing great stuff with limestone and different kind of cement formulations and cement chemistry. We think there's a better way to make cement that isn't the same chemistry.
And when you say industrial waste, you've thrown it out a few times.
Yes.
What exactly is included in industrial waste?
Yeah, so we think about metal slags, mine tailings, different kind of byproducts from big industries. So for us, we're only interested in if you are making more than 500,000 tons of it a year.
And what happens to this stuff now? Is it just being...
So landfill.
So you're trying to do a double dip here.
Yeah, because we just believe that these industrial wastes will be the mines of the future. We believe that they're going to be the way that we have to think about resource management.
Yeah, and it's about keeping us within these planetary bounds, making sure that we are reusing to the best of our ability the materials that we're extracting from the earth.
Yeah, I think there's amazing things that can be done with them. I think our process is one of those processes, but I know there's a lot of great startups doing things with waste, because I think the waste revolution is going to be kind of super amazing and exciting.
So you talked about there not being one material to rule them all, to use a Lord of the Rings reference, right? There's going to be multiple materials that are necessary to realize this change in the cement space. Are there that many cements out there right now? This is this is coming from a place of ignorance, but we have you here to sort of educate us in the audience about it.
Yeah, so there's different cement blends. Okay. So there's like OPC, so ordinary Portland cement, it's like the main one, but then there's supplementary cementitious materials that are added to it. So kind of like fillers or additives we can add.
Okay. And that is to stabilize it, or to what are those fillers?
Usually to reduce emissions. There's different ones that add different kind of durability properties. There's different ways we think about those.
Okay.
The problem is that those supplementary cementitious materials are in short supply. So there's just not enough of them globally. So how do we make more of those? How do we kind of think about different applications needing different types of cements, and not kind of have the current mode of thinking, or has been the mode of thinking before, is, oh, we'll just make it over strong. We'll almost over-engineer everything in it, and we'll not really think about how we can be smart with our resource.
I have a random question I'm just going to throw in here, and I'm not sure if we're going to keep it at this particular moment or not, but I can't help but thinking about when you talked about we're just going to make it super strong, this like trend that was on social media for a while is like, how often do men think about the Roman Empire? And I know that the Roman Empire, the concrete, has lasted many, many years, and there's some story that I heard about why that's the case around it being cracking and there's being it to fill in and for it to reposition. Sort of when you think about that, like how do you sorry, I lost my train of thought. When you think about the sort of durability of concrete, how do you imagine or envision a world where we want to build buildings that last longer and maybe have the same kind of durability as that the Roman Empire might have had? Yeah,
no, I think that's a great question. I think for me, it's some of the testing we do now still is quite archaic. I think some of the testing feels, especially for concrete, hasn't really caught up with the advances in science. So we're very much pushing the envelope on, but let's get to the nanostructure of it. Let's really understand it. So for us, we make a 3D nanostructure, which is very different to normal cement, which is a bit more of a platelet structure. It's not that full 3D nanostructure. So that nanostructure gives us way deeper and kind of more durable structures. So you're not getting those kind of, you've probably seen it on buildings, where you see the rebar and the concrete's falling off, the concrete cancer as we'll call it. We're not getting that because you have a different type of structure. I think it's really understanding what durability do we need? What is the kind of lifetime we want for a building? Should all buildings be able to be kind of taken apart And is there that, like, do we think there should be a management piece on, actually, I own the cement, so you have to return it to me? Like, I think there's a really interesting thing in that. Like, how do companies who are manufacturing things take responsibility for them for their whole lives?
I think with respect to cement, that would be very interesting to think about, you know, a long-term rental.
So I think concrete as a SaaS product would be a very interesting way to think about it.
Earlier, you mentioned that there's also a software component to the work that you're doing. So we've talked about the hardware element of sort of the material science, but let's talk about the software.
Yeah, no, it's a great question. I think for us, we think about this in kind of three key buckets. One of them being a material consistency. So these industrial wastes, they're not consistent. It's kind of like mining and understanding how you get the same product every time. Then there's a piece around formulation. So how do we understand the chemistry that's happening inside of these, so that then we can predictively model out from different waste feedstocks how they become cement. And then the third is about kind of this, what happens in the future? What's its longevity? How do we think about an application? And we kind of think of those as our three key buckets. Because I think that for us, really understanding the materials deeper, understanding how we can bring that through, really helps us to start to own the feedstocks as well.
And so is the work of the software then focused internally for you all in support of the development of the products that you want to sell? Or is there also an opportunity for outside individuals or companies that might be interested in making their own formulations or mixes to also use the software that you all are developing?
Yeah, so at the moment it's internal. Because we think it gives us a huge edge. We think it really helps us understand things. There's been a lot of interest to use it external.
I would imagine.
But at the moment, we're keeping that internal. We think it's a really great kind of Swiss Army knife for us.
That's amazing. And tell us a little bit about the team. Obviously, you're the founder and you are the one that's like, you know, clearing out the garage to get things started, but this is not something that one does alone. And you guys have raised some money now, quite a bit of money to build this. And we talked a little bit about the factory that's coming online soon. Or plant, what do you want to call it?
Factory?
Factory, yeah. Cement factory is what I was like. The factory that's coming online. So I'm curious, like what kind of support have you needed in getting this from, okay, I want to change the way that this industry works and I want there to be more materials, to, wow, we actually have materials in our hand?
Yeah, no, I think it's super interesting how you build a team, right? I think going from a spreadsheet to a factory is very different. It's been a journey. And I think, so I have a co-founder. So my co-founder is kind of polar opposite to me, I think, is the best way to have a co-founder.
Yes.
He's very focused, very good at delivering stuff. I can do the vision. I can kind of build all of that stuff. He's very good at making sure we deliver what we said we would.
I always say that you need leadership skills and management skills if you're going to be a successful startup.
Yeah.
You can't have one without the other because they're both necessary.
Yeah. And then we have an amazing CSO, so Chief Scientific Officer, who's kind of at the cutting edge of research, technology, how you bring that through. And I think for us, it's been how do you build commercial relationships? So
is that what you spent most of your time doing?
So I just spend a lot of time doing that and product and kind of trying to keep me out of everything else is what my other co-founder's job is to do.
Are you one of those that like need to be told you need to go work on something else?
They have to kick me out.
Well, it's
you have to care, right?
Exactly. And you have to care about all the pieces if you're running the business. You can't just be concerned with the commercial relationships because then you're not getting the product where it needs to be. And you have the role of spinning up this factory. Tell us about what that experience has been like. Is this the first time you've done this?
Yeah, so this is the first time we've ever done this. It's the first of its kind facility. So that was fun. Like when we started, we nearly got stopped so many times. Like one of them being, we forgot to check how much electricity was on site. Like the rookie error of like, oh, can we actually plug it in?
Is this brownfield or greenfield development?
So this is actually co-located with a customer. So we kind of thought it would be fine because you're like, oh, they're already there. Obviously, they'll have enough energy. Like, obviously. So that was a fun 2 weeks as we were like, it's 18 months to get a new electric supply to that site.
Wait, did you actually need to get new electricity? Okay.
No, so we were able to use a substation and dig a really big trench, like half a kilometer to the site, which was good, apparently. That was a good way to solve that one. I think just trying to get, so we used a multinational team to get this build across, because part of them made the reactor, part of them made the silos. So we had a lot of interesting things come up just in terms of like health and safety, different regulations in different countries. So trying to get people to be able to build on site.
Wait. So let's take, you have now taken, I realize now that you all have created a technology, and to date there has not been done at scale.
Mm-hmm.
And now this process that you're going through is being able to produce at scale inside of this factory. So you were buying components. Had these components been used in this way before?
No, so they'd not been used in this way before. There was bits like silos and kind of things like that were standard, but the whole inner factory, new, trying to pull it together, trying to get people to do us favors, because you're like, come on, we'll die if we don't get this. They can wait another 6 months. Come on, like the amount of times I had to use that, like, please don't let us die. Bump us up the list. Because like there was a silicon shortage, so you couldn't get motherboards and things like that, and control panels. So you end up being like, how do I get it? Can I buy it secondhand? Can I buy it from an old machine? How do you fix this in? Like, this has to be solvable.
eBay.
Yeah, eBay was not our friend that time. We tried and we tried. So there was a lot of negotiation on how do we deliver this quicker? How do we pull in favors? How do we network into this and be like, oh, but when we build the next one, we'll use you guys as well. And I think like being like, oh, we know that if this works and scales, this is going to be huge, and we want to work with you long term. So how do we build that in? So I think we had amazing partners on the factory, really pulling that through. Also an amazing partner in terms of the company we were building with, Sigma Rock.
Yeah, I was gonna say, like, how did that commercial relationship come into being, and like what kind of commitment did they make to you all to get this off the ground?
Yeah, so they've been really supportive in terms of how we build. I think really championed by Mick, who's there. I'm not sure what he is now. His title change, cut that out. Yeah, who's managed by Mick. He's been a great supporter, kind of that champion that every kind of startup wants in any company, pushing us through. They made an investment in the last round, so just really kind of championing us scaling and us growing with them.
That is amazing. And now this sort of co-location is it for a specific purpose that they have in mind, or a specific project? Like how does it work with respect to what you all are building?
Yeah, so the plant will produce up to 150,000 tons of cement from it.
And in the world of cement production, where does that fall in terms of capacity?
So most cement plants are about 1 million tons.
Okay.
So it's smaller, but bigger than most first-of-a-kind facilities in this space.
Okay. Hair flip. Bigger than most facilities for the first time in this space. Okay, that's really amazing. And this is the, obviously, how long until you're operational with respect to...
So in the next couple of weeks, we're hoping to have product out of the plant that's on spec. Wow. But I think commissioning's hard, so I'm trying to be... it could take us to the end of the year to get the plant running efficiently.
I mean, yes, it is a new factory, so...
We're learning on the job. I think there's a lot of learning opportunities that will really help us with the scaling in the future.
Excellent. In terms of, your own growth as a founder in the space, like what would you say have been some of the most exciting elements of building Material Evolution over the past few years?
Yeah, I think it's been a ride. I think one of the most exciting things was when we got the reactor the first time. So it was my 30th birthday when it arrived, and the best present you could get was this reactor, because we only had it for 2 weeks at this point. So they were like, you can loan it.
Oh.
And we never gave it back.
This is ours now.
Yeah. I was like, so how much do you want for it? We're going to keep this, and we're going to keep using it. And they were like, you can't buy the show one. And I was like, well, clearly I can. And then he gave me a price, and I told him that was too expensive.
He's like, it's here, so you can come and pick it up.
I was like, but it's been used, so it can't be like full price, can it? So that was super exciting. I think building the team and like getting amazing people in the right places in the team is super exciting. building the commercial relationships, like as you kind of are like, oh, people really want this, like this is super exciting, how do we work with them? And then, I mean, when you going to the factory like a few months back was like super kind of exciting to be like, oh, it's kind of, we've gone from the garage to this, like this is crazy. And it's been what, 4 years?
What would you say is one way that you feel like this particular industrial area cement is sort of ripe for, obviously from an environmental perspective, but from a business operations perspective, do you think there's opportunity for change there and innovation there as well?
Yeah, I definitely think so. Like I think there's a huge push now for collaboration, partnerships on these things. I think also in terms of like customer service, because I think there's a really interesting piece that sometimes people forget to do customer service.
Even for cement?
Even for cement. Well, cement's commoditized, right? So especially a few years ago, they had a cement shortage. So at that point, we don't really have to try hard to sell cement. Like you need to buy it from us. It's always done on price mostly. So people are pricing out, like, if you're buying this much. I think there's a really interesting piece on customer service, and then getting the right kind of talent. I think there's a big talent gap in there.
Okay.
And I think there's a lot of talent missing in terms of the construction space, which I think is really ripe for disruption.
You spoke a little bit about alternative models in the future, and I kind of want to go back to that because I had never thought about, cement as a service. And I'm curious what other things you have up your sleeve with respect to, like, business models that are related to, total life cycle management for cement and concrete, renting. Like, what other things have you thought about as like wild ideas that might, hopefully one day make their way to the center of the way that we actually do business?
Yeah, I think the renting piece really, I think is super exciting. Like, do they never own it? Are they leasing it from us forever? And then when they don't want it, we take it back. I think I like the idea that you take responsibility for what you put out in the world. And
what would taking it back mean?
So we've done a bit of work on this because I was super excited about this. Okay. Was how do you grind it back to its components? So with construction demolition waste, there's a big thing in that, which is recycled concrete. So old buildings crushed, can we get the cement back out and activate it?
And how successful is that generally based on the technology that's out there?
There's some that are doing great things. It's not widely adopted at the moment. I think there's a big supply chain logistic problem there that people are really overcoming, is like, how do you move it? How do you get it in the places it needs to be crushed, screened, and got back into its parts?
Is there also a contamination issue because there's a lot of materials that are involved in a building that's not just cement turned concrete. So is there an issue there with breaking out the materials as well, or is that part pretty easy to...
I think that part's easier to solve.
Okay.
For me, it's more the logistics, like how do you make sure you've got enough of these smaller hubs to do it, but do it in an economical kind of way? How do you make sure the fines are usable? Because I think that's the cement paste. How do you rehydrate that? There's people doing great work in there, and I think really exciting kind of pieces are being done. We've got some tech that we're working on in that space because I think it's a really interesting way to kind of think about it. But I think... And
it fits into this thesis that you're talking about, right? Yeah. If we're going to put it out there, we have to be responsible for taking it back at some point.
Yeah, so I think for me, it's us really thinking as makers or producers that, at some point, I think we should be able to take it back. We should be like, oh, of course, can we have it back? Can we loan it to you? I'm not sure the cement industry is ready for that yet. But I'm always wanting to know that we could recycle our material back. We could get back to cement. And we could recycle that all back. I got really obsessed at one point and was like, can we put like some sort of thing in the 3D nanostructure that almost is like a DNA mark, so that forever we'd know it was ours and it wouldn't matter who bought it and where it went in the supply chain. We can't do that scientifically yet. So that was one of my ideas. I was like, imagine if we could always find Mevo cement. Imagine if it glowed under UV light, and that's how we find that it's ours. But I think that it's just a really big responsibility that clean tech needs to take as well as they build these new materials, is that, okay, but how are we going to take it back? How do we think about this? How do we get the industry ready for that as well?
So we talked a little bit about industry now. I'm curious, what has the there's been a boon of investors who invest in climate tech. What has your conversation been like along your fundraising journey for the startup with investors? Have they immediately gotten it, or has it taken some convincing, or working more with people who are industry experts versus generalists? Just curious what that experience has been like for you.
I think depending on the investor and if they get hardware, depends on the level of kind of journey we need to take them on. I think getting people excited about cement has become easier. People are more excited about cement, which is always fun. But I think it's how do you tell the narrative, right? How do you get people up to speed quickly, and how do we make it easy for them? I think for me, I've always been like, oh, just come and see the factory. Why don't we come and make some concrete with us? Let's show you the cement. Let's show you the process. Let's make concrete.
And when you take them to the factory, like, what are they? Are they like, wow?
I think they're like, oh yeah, this is great. Like, I can touch it. I can feel it. It feels real. It feels like we're doing something. And I think that really helps people get it. I think otherwise it feels very ethereal. It doesn't feel grounded. So we've really worked on that, bringing people in on the journey, bringing them to the factory, getting them to touch it, feel it. And then I think really building that customer relationship so that you're like, oh, but go and talk to these experts, like let them tell you, so that we're not doing the hard sell. You're talking to the experts who want this, and this is how we scale together.
That's very interesting. And obviously it's worked, and hopefully it continues to work with respect to the next factories that come online in the future. With respect to your positionality, I obviously, we've been interviewing people for the podcast, and within the space of industrials, there's not a lot of women, and I'm wondering, what your experience has been like engaging with this old, stodgy, male-dominated space.
Yeah, no, I agree that I'm usually the only woman in most rooms, especially when we start to talk commercial. But I think that's changing. I think there's amazing women coming into power, especially in the big cement companies. I think that, I guess how I think about it is that we can't change everything, but we also need to push for those things, push for those kind of equality pieces of, okay, but we can do great things together. I think I make them uncomfortable sometimes, as you can imagine.
As you should.
But it's kind of fun to do.
Yeah, make them crawl.
But I think there's kind of this piece that, how do you get technology in? I think sometimes it maybe cuts through the noise that I'm not the same as them. That it actually kind of helps that I'm not the same. We usually use social capital to get all these meetings. So we have our people who've got that kind of network that are working with us commercially, so they open the doors, which I think makes a big difference. And then it's something different that's coming through. It's not the same as they've seen before, which I do think helps.
Yeah, you're bringing the innovation on multiple fronts.
Yeah.
That is really, really interesting. So now, unless there's anything else you want to share about Material Evolution, about your journey, we're going to go into our rapid fire questions.
Okay, perfect.
You ready?
I'm ready.
I will ask you some of these questions, and we just want to get your feedback on them. All right. So the first one is, what's one thing you wish you knew before you started the business?
I did have an answer to this earlier as well. I have so many things.
It could be multiple things.
Can we do a few and then you can choose which one you like?
Yeah, ask the question again. What's one thing you wish you knew before you started the business?
The hardware is really hard. That it will test you in every way possible. And I think finding the silver lining in every situation is so key.
What's the hardest part about being an entrepreneur that no one told you about?
People. People are the best and hardest asset in any company. I feel like probably people would have told me this if I'd knew what startups were before I started it.
Yes, people are wonderful, but also terrible at the same time.
And it's a constant struggle, right? You're like, oh, you're the best. And then sometimes...
What's the best piece of advice you've gotten since you've been on this journey?
If you're not getting scratches, you're not going fast enough.
I like that. Mm-hmm. If you could have dinner with any founder, dead or alive, who would it be?
I was going to say Al Gore just for jokes.
He's alive and he's a founder. Yeah. We'll take it.
No, but just because of the other story where I didn't know who Al Gore was.
We'll also cut that. In case you raise from generation in the next round.
We do not want to tell them that. I don't know if I have a good answer to this one.
I'll ask it again. If you could have dinner with any founder, dead or alive, who would it be?
I want to say Steve Jobs because I want to know if he's a neurotic, as everyone said.
That's a good one. What's one failure?
That's a good answer, though.
Why not?
I just don't think it is.
Yeah. He's like...
I want to know how neurotic he is, just for the banter.
Yeah, I'm sure you don't push crazy products like that change the scope of like how human beings interact with technology without being a little crazy. And I would like, how far does the crazy go?
Yeah, like where's the level of crazy? Like, is there an edge?
What's one failure that turned into an opportunity?
I'm trying to think of just one.
I was gonna say, I guess you've been doing like research and development.
It constantly fails.
So it's like every failure is an opportunity.
Yeah, I think it's some days we fail more than we would like, but it's taking the lessons from it. I'm trying to think of one that's a good one. I mean, there was a failure that we had with one of our next version materials where we couldn't get it to work, and it worked before, and we didn't understand why it wasn't working now. Being on the cutting edge of research is fun, because then no one can help you with what's happening in the tech. But then what we did learn from that was that actually there's a different kind of chemical formulation we can make that stabilizes all of our kind of products and makes it a lot easier to do. So was really hard because for months we could not understand why it was happening, and we kept getting different results. And all of our scientists were having this inward fighting because everyone's like, but my results are right. You can't do your job. You don't know how this is done. So that was a really hard time because you're trying to develop a product, you're trying to scale it, and you don't know why it's happening. But I think what we got from that was, okay, we understand the science more. We've now been able to stabilize products better. So it was a great kind of revelation. But at the time, it was a painful thing.
What's your ultimate productivity hack for getting more stuff done?
I love a plan. I love to do a Sunday night plan. And then we do this thing called Mission Control.
Okay. Which
is just basically our weekly stand-up, but we like to call things fun things. It makes it a bit more fun in the startup world. It's my 3 big rocks. What are the 3 things that you have to complete this week that are non-negotiable? No matter what happens, you are going to make these happen. Even with the chaos that comes with the startup, these are the 3 things you're going to get done.
Excellent. What's one piece of content that every founder should consume? Be it book, podcast, movie, show?
Essentialism. I think it's great for the art of saying no, because I think it's really hard as a founder to be like, how do I prioritize? I'm going to use my time. How do I get to know quicker? I know some people are amazing at that, and I've met founders that are amazing at saying no to everything. I'm still working on that, but I think it's a great skill.
What's one habit that has transformed your business?
I think it's the habit of us meeting twice a week. So I meet everyone on my team for half an hour on a Monday and 15 minutes on a Thursday, where we check in, we find blockers, and we talk.
I like that. That's the good operational strategy. And if you could only use one app to run your business, what would it be?
So I really love Notion. I feel like Notion's like the easy one that everyone loves, but I love Notion. It's pretty, it's visual, and it's just so good at keeping your brain organized.
I would agree.
But I do like Miro too.
Miro board is awesome.
Love that for collaboration. Looks pretty. You can see the architect coming out of me now. As I'm like, and it looks beautiful.
Well, that is the list of questions that we have for our rapid fire section. It's been so wonderful to talk to you, Liz, and to learn more about material evolution. And I'm really looking forward to following the journey, and maybe the next time I'm back, going to visit the factory myself, because I want to see how the cement is made. But yeah, thank you for coming on Reindustrialized.
No, thank you for having me. And of course, you're more than welcome to come to Wrexham. We'll get you up those silos.
Oh, I'm excited.
Thank you so much.
Thank you.